Proverbs chapter 3, verse 5 and 6. Trust in the Lord with all your heart. Do not depend on your own understanding. Seek His will in all you do, and He will show you which path to take. Good morning, everybody. It gives me immense pleasure and honor to welcome you all to the prestigious occasion of our school's Hands-on Science.
This year's theme for Hands-on Science is Science Olympics.
That means science of sports.
Science has been involved in sports for the past few decades. Thanks to new technologies and understanding, scientists have been able to achieve great results and delve into different aspects of sports.
Welcome to the Science Olympics League 2021, where everyone's a winner.
We are at the side and look, everyone is blooming in the spirit of Science Olympics. Look at their sheer determination and skill. Now without further ado, let's start.
We request Pooja Kumari to commence the program with a word of prayer.
Thank you, Father, for giving us this beautiful day and the opportunity to showcase the wonderful experiments and projects done by the students. Thank you, Lord, for each and every participant, parent, teacher, and technical staff who've put in their efforts to make this program a success. Bless our viewers too. In Jesus' precious name we pray. Amen.
Thank you, Pooja. Now let us start the program and learn about the science behind the glowing torch.
Good morning, everyone. Did you know in the year 2000, the Olympic torch spent 3 minutes submerged in the Coral Sea? In 2008, climbers carried it to the summit of Mount Everest. And in 2016, in Brazil, the torch even took a ride on a surfboard. How was all this even possible? All of this was possible only because of the intelligent designing of the torch and the usage of a fuel which was safe and reliable at the same time. So while designing an Olympic torch, a few things are needed to be kept in mind. For instance, the aesthetic design of the torch gives very less space for the fuel, and the quantity of the fuel must be enough to produce a yellow flame of about 10 inches in height and must have a burn duration of a minimum of 10 minutes. In the most recent Tokyo 2021 Olympics, for the first time, hydrogen was used as a fuel source. Hydrogen, unlike propane, did not produce any carbon dioxide. The organizing committee had aimed to eliminate carbon emissions and spread public awareness regarding the environmental issues. This hydrogen-powered torch could easily sustain heavy winds, light rain, and matched all requirements. That's all from me. Over to the hosts. Thank you.
Our first group of contestants are from the junior category, the Newtons. Let's see what they have in store for us.
Hello everybody, my name is Jonathan Binu from Mount Carmel School Class 4C. Today I'll be talking about reaction time. Let's do an experiment. We'll just need a note or a piece of paper. Hold the note at the top corner with your left hand. I'll drop it and try to catch it with my right hand. Now this time I'm going to do the same while my sister is going to drop the note. Yay! I got it!
What's happening? When I dropped the bill, my brain was able to send a signal to the other hand, telling it to start catching it. When my sister dropped the bill, I didn't have that head start.
The typical human reaction time in this experiment is around 0.2 seconds.
Many sports like boxing, fencing, badminton, volleyball, wrestling, etc. require the sports person to react quickly or at the appropriate time. All athletes get the same training, but to win they require a quicker reaction time.
Albert Einstein once said, Imagination is more important than knowledge. Knowledge is limited. Imagination encircles around the world. Hope this experiment was informative. Thank you.
Hello everyone. I am Ananya Luhia of Mount Carmel School. Do you know, on an average our heart beats 72 times per minute? The heart is a special muscle that pumps blood around our body. A healthy heart keeps us fit and active. You know, our wonderful players of India exercise a lot to keep their heart and their body fit. And that's how they make us proud in international events like Olympics. So, how does the heart pump blood? Let's find out with an experiment. Here is the model I prepared using a jar, balloons, straws and colored water to demonstrate the heart. Our heart has 2 upper and 2 lower chambers. The top chambers are called atrium, which fill with the blood returning from the body. The bottom chambers are called ventricles, which squeeze and pump the blood out of the heart. Each chamber also has valves that control the blood flow. When valves open up, blood flows from the atrium through the ventricles and then out of the heart. The valve, which is a small balloon here, prevents the blood from flowing backwards. In the model here, the heart is filled with blood. When you press down the balloon, or let's say the muscle of the heart, the blood squirts out. See, it's flowing out continuously. Isn't it interesting? So friends, this is what our heart does continuously throughout our lifetime to keep us alive. Thank you.
In sports, some players don't drink water in between their tournaments and hence they get dehydrated. And some players drink water but more than the required quantity. Hence, they get cramps in the stomach or even get injured. Let me give you an example of a basketball player.
Here is a basketball player. He drinks a lot of water before his tournament. He couldn't do his goal because of his stomach cramp.
Keeping in mind this situation,
I have created this hydro unit circuit.
So, this circuit will ensure that the sports player will drink the right amount of water. In this circuit, I will use some electrodes, a buzzer, a 9-volt battery with a battery connector, a switch, a container filled with water, a breadboard, an LED, 2 transistors of BC547, 4 resistors, 3 of 1 kilo ohm and 1 of 10 kilo ohm. Now, let's start making the circuit with the help of my circuit diagram. Now, my circuit is ready. So, when the athlete drinks the water, let me off the switch. So this beep will indicate the athlete to not drink the water beyond the measured level.
I have fitted my circuit inside the bottle. Now let's see what happens.
Hello friends, I am Jayat Narayan from class 7th F. Did you see the recently concluded Olympic Games at Tokyo, Japan? There I watched a number of TV events like hockey, basketball, gymnastics, archery and many others. The game which impressed me the most was the basketball. Do you know why? The standard basketball is played with 5 players on each side. It can be even played 3 on 3, 2 on 2 and even alone. Such is the beauty of this game. By watching this game, I found its health benefits like improved body muscles, body coordination and self-confidence. So, as to understand the science behind this game, I found the best way was to make a model of it. Here is my model. It has basket and a ball, all fitted together in a carton box. So, when an amount of pressure is exerted on the catapult, an opposite reaction takes place, which puts the ball inside the basket. Now let's see. Let's try once more. I need to practice more. So, here we can see that the Newton's third law is being applied. For every action, there's an equal and opposite reaction. I hope that this small model of mine would actually inspire many to play this game on the court and bring glory to our nation by winning medals in the sport. Thank you.
Good evening, everyone. I am Lumnina Burgoin and I am a welterweight boxing player.
And I am Kamalpreet Kaur. I am a discus throw player. As a player, we need to keep our diet plan and workout sessions under control. Let us try and understand some of our tricks to keep a check on it.
A diet plan varies from time to time. The pre-match meal should be abundant in simple carbohydrates such as white bread, cereals, fruits, etc. Slightly loaded with proteins, digestible and with little fat.
We athletes have to be very careful on what we eat and what not. Basal metabolic rate is important whether you want to maintain your weight, gain your weight or even lose your weight.
Now, this is the Harris-Baratek formula. This formula is replaced by a simpler formula.
Ourselves in just a fraction of seconds. Let's see how. For men, the formula is weight per kg into 10 plus 900. For women, the formula is weight per kg into 7 plus 700. So, lovely, now what is your weight?
My weight is 69 kg.
69 into 7 plus 700. Now 69 into 7 is 483 and 483 plus 700 is 1183. So your BMR is 1183.
Wow, it's amazing. Different organs of our body consume different rate of BMR. Our liver consumes 27% of our BMR. Our brain consumes 19% of our BMR. Our muscles consume 18% of our BMR. Our kidney consumes 10% of our BMR. Our heart consumes 7% of our BMR. And other organs consume 19% of our BMR. So metabolically, our liver consumes most of our metabolic rate. The BMR can help determine what number of calories you should be eating in order to meet your goals. If you want to gain weight, you have to eat more. If you want to be healthy and fit, you can try this with the help of science and calculate your BMR on your own.
Thank you.
Mind-blowing. Now let's take a short break. But you all, stay tuned for a performance by our sponsors, Mount Carmel School, Physics, Chemistry and Biology Lab.
Hello everyone, I am a sports scientist and today I am here to help sportsmen with techniques and strategies for the game. I use a lactate meter to measure the lactate of the athlete right after their workout. The lactate test is a reliable guide to safe and effective training for athletes. It helps the athlete avoid overtraining, which can lead to exhaustion. This is why lactate tests are beneficial in an individual's performance. I also check their speed endurance. The purpose of speed endurance is to prolong the amount of time where a near maximal speed can be maintained. Using a device, I am able to record all of the athlete's movements, which help me to plan strategies and techniques for the athlete when he is playing.
Now let us resume with the next contender from the category, the Edisons.
Greetings to everyone. I am Saicom Mirabai Chanu and as you know, I am a weightlifter. Weightlifting is a sport involving lots of strength. A lot of that strength comes from the muscles in our body. They provide the flexibility and lifting power, which allows me to lift weights more than twice my body weight. All the movements in our body are assisted by muscles. The basic motion of contraction and relaxation of muscles is the main driving force behind movement. Muscle strength is very important for overall health, as it is vital not just for weightlifters like me, but for each and every one of us. A vital ingredient to improve muscle mass is proteins. So when your mother gives you eggs and paneer, eat it. Now let me demonstrate to you how muscles help in moving my arms. Over here I have a model of the human arm. This is the upper arm, this is the forearm, this is the muscle, and this is the human hand holding dumbbells. As you can see here, when the muscle contracts and relaxes, it helps in moving the forearm, which helps me to lift heavy weights like dumbbells. Thank you.
Applications: helps in body movements, maintains body posture, helps in joint stability.
Greetings everyone. I, PV Sindhu, a badminton player, would be giving you an insight into how the players manage their diet to fetch energy. Those of us who are involved in sports understand the importance of fueling the body to maximize the energy and performance. It also helps to understand how the body converts energy so that healthy strategies can be used to improve athletic performance. To understand this concept more clearly, let's perform a simple experiment.
So first I've taken a piece of potato and stuck it to a skewer and to a piece of clay. Now I will take a test tube and add 20 centimeters of cubed water. Now we'll measure the temperature. Our starting temperature is 22 degrees Celsius. Now we will burn the food sample. We need to let it burn completely. After that, we'll use the heat being generated by the potato to heat the test tube. Now we'll measure the temperature. The temperature is coming out to be 45 degrees Celsius. Now, to find out the amount of energy released by that food, we use the equation energy equals mass times specific heat capacity times change in temperature. I have used my calculator to find out that the value of energy content per gram of potato is 4025 joules per gram. With the help of this experiment, we understood that how much energy is released by a food sample. Using this experiment, the players can determine the energy content of their food.
Good morning everyone. Today I, Jasjot Singh of class 8th will be explaining something about the Magnus effect. So what is the Magnus effect? Well, have you ever wondered how the famous footballer Roberto Carlos kicks the football and it curves around the defenders? Or what is the science behind bend it like Beckham? Well, let me show you a clip. Wow, wasn't that amazing? So how is that the footballers are able to bend the ball along the curve as it spins through the air? Well, now I have my friend Harshit from class 9 who will explain this through a demonstration.
Good morning all. For this demonstration, you will require 2 styrofoam cups, tape and a few rubber bands. First put 2 cups on top of each other. Now tape them together in the middle, just like this. Now for the rubber bands, you need to knot 4 bands just like this. Now we wrap the rubber bands around the cup, like so. Our model is ready for demonstration.
Thank you, Harshit. That was indeed wonderful. So how are the cups changing the direction Well, the answer lies in the Magnus effect.
As the ball is spinning, the top and bottom of the spinning ball drags the air in two different directions. As a result, the speed of the ball is reducing from the top and increasing from the bottom. This difference in the speed causes a difference in air pressure as well. This difference in pressure creates a net downward force and the ball ends up curving downwards. So this is the Magnus effect. Thank you.
Greetings everyone. I am Sanya Shah of class 8A. Today I will be demonstrating the science behind the javelin throw.
We are proud of Neeraj Chopra winning the gold medal in the Tokyo Olympics in javelin throw. His immense hard work and dedication helped him. But do you know science also helped him? You might be wondering how. Let me explain. A javelin throw is a track and field event where the javelin is thrown. The javelin thrower gains momentum by running within a predetermined area. The objective is to throw furthest with maximum force so that it will land within a prescribed marking area. Let us see through an experiment how the projectile trajectory of a javelin is influenced by its release angle. The materials required are paint, color palette, scale, block, marble and a plain sheet. In this experiment, we will record the motion of the ball as it rolls across and down a slanted table. The paint trails left behind by the rolling balls are parabolic curves. We will reposition the height of the ball and also angle of the ball to get different parabolic curves.
We observe an object which is projected at different angles cover different distances. The distance covered by an object depends on the angle of release or projectile. However, as the javelin is released at a height, studies show that the optimal angle of release for a javelin is 34 to 36 degrees.
Physics and sports are connected. Understanding the laws of motion can affect all areas of sports, from helping athletes move faster, preventing injuries, planning more efficient training, developing aerodynamic equipment and clothing.
Stay curious, keep experimenting and keep learning. Thank you.
Do you know how safety gears protect us? Or what are Newtonian and non-Newtonian fluids? Let me tell you this by a simple experiment. In addition to his many other discoveries, Sir Isaac Newton did some groundbreaking work with fluids. He discovered that the viscosity of most fluids is affected only by temperature. So Newtonian fluids are the fluids whose viscosity is affected only by temperature. Examples are water and oil. Non-Newtonian fluids are the fluids which don't obey the usual law of physics. That is, the viscosity is affected by agitation or pressure, also known as shear stress. Have you ever tried mixing cornstarch with water? Well, let's see what happens.
Add water until it becomes a mixture like this. As you can see, at high shear rates, the tight bonds do not let the molecules move and the mixture behaves like a solid body. But at low shear rate, the molecules spread out and untangle and the mixture behaves like a liquid. This is called non-Newtonian fluids.
So this material is used in safety gears to protect us from severe injuries. The material hardens up when a lot of force is applied and softens when less force is applied. So now you know how safety gears protect us. Thank you.
Now let us have another performance by our sponsors while we take a teeny tiny break.
Evidence is like a clue that something is true. Scientists collect evidence through observations and experiments. Scientists use evidence to understand the world around us. Around us. We need evidence to help us support our ideas. The more evidence we have, the stronger our idea is. Scientists use evidence to understand the world around us. Around us. Evidence is like a clue that something is true. Scientists collect evidence through observations and experiments. Scientists use evidence to understand the world around us. Around us.
Thank you for the incredible performance. And now, let us resume with our senior contestants, the Einsteins.
Good morning everyone, I am Akriti Jha from class 9th and today I'll be sharing some information about sports drinks. Sport drinks are flavored beverages that often contain carbohydrates, minerals, electrolytes and sometimes other vitamins and nutrients. Sports drinks are isotonic, which means they have the same osmolarity as body fluids and are the most effective way to rehydrate during and after exercise. The fun part is that you can make your own sport drink at home. The ingredients I'll be using are 1/4 cup of lemon or orange juice, which would be the citric acid, 2 cups of water and 2 tablespoons of raw honey, which will act as the carbohydrate. The process is simply putting everything in a mixer and blending it. Starting with some citric acid, some water, honey as the carbohydrate, and lastly some more citric acid. Blend it and enjoy your sports drink. Thank you for watching.
The 7-year-old Sachin Prakash is India's top swimmer and contender at the Tokyo Olympics 2020. The young swimmer breached the Olympic qualifying time and broke his own national record.
Is swimming possible without surface tension? The thing that gives water its surface tension is called hydrogen bonding. If there was no hydrogen bonding, it would be a gas. So no, swimming wouldn't have been possible without surface tension. Now what is surface tension? Surface tension is the tendency of liquid surfaces at rest to shrink into minimum surface area possible. Now let me explain the concept of surface tension to you with an activity. For this activity, we require a glass of water, a rubber band and a stick. Now take a glass full of water and place a rubber band gently on its surface. The rubber band will float on water surface. Now push the rubber band by applying some pressure on it with the help of a stick. The rubber band sinks. So we observed that the rubber band floats when put gently on the surface of water and it sinks when a little bit of pressure is applied on it. We concluded that water tension helps the rubber band with much higher density to float on water surface. Now what gives water its surface tension? In this activity, the rubber band floating on water is actually being held up by the hydrogen bonds.
I am Shreya Shokeen
from class 9th A, and today I'm here in front of you to present a very interesting problem known as the Brachistochrone curve. Now let us see what exactly is this problem. To understand this problem better, let us review a case study which is none other than a skiing competition which is occurring right now in Australia. Player X and player Y both have the same mass. So which factors would actually affect their descent down to the mountain path? Let's view it in a short demo. Here, player X is denoted as the yellow marble and player Y is denoted as the blue marble. The shortest distance covered should have been the straight line, but why is it so that player X reaches the foothold before player Y? To understand this, let us view the equation given by John Bernoulli, a Swiss mathematician. The method used to prove this was the Snell's law, which is the law of refraction, a formula used to describe the relationship between the angles of incidence and refraction when referring to light or other waves passing through a boundary between two different isotropic media. Therefore, to mimic this, Bernoulli used light to show the fastest possible route. All he had to do was add more and more thin layers, and as light followed the fastest possible route, well, what do you know? The Brachistochrone curve was created. In conclusion, the Brachistochrone curve is the curve of the fastest descent.
Good morning everybody. My name is Raghav Datta and I am from class 9A. Today I'll be talking about muscle regeneration. What was the reason behind Neeraj Chopra's historic throw of 87.58 meters? And how was Mirabai Chanu able to lift a whopping 202 kgs? Yes, it was because of muscles. Muscles, along with connective tissue, bind us together and they help in movement and locomotion. An average human body has 656 to 850 muscles, and they make up about 1/3 to half of the human body weight. Let's see with an example how these muscles work. Suppose in a time after Corona, you and your friend decide to lift the heaviest weight that you can. In this case, the brain will send some neural signals to the motor neurons in your arms and legs. The membrane of the muscle cells is lined with sodium ions on the outside and potassium ions on the inside. When the brain triggers the release of acetylcholine, the pores on the membrane of the muscle cells open, causing sodium ions to move in and the potassium ions to move out. This causes the development of an electrical charge known as action potential. Action potential triggers the release of calcium stored in the muscles, which causes contraction of muscles. The energy to do all of this comes from adenosine triphosphate. It is responsible for the rearrangement of ions. Thank you and have a nice day.
Did you know, since the 1904 Olympics, the instances of doping have been quite widespread, and it took us 95 years from then to form a World Anti-Doping Association. In the modern era, performance-enhancing drugs have taken varied forms from pills to injections. One of the most famous, or rather infamous ones doing rounds today are anabolic steroids. These are steroids that replace testosterone to increase sprinting ability and muscle mass. Before we move on, we should know what a steroid is. An organic compound with 4 rings is a steroid, but the ones that athletes use are anabolic steroids. They stick to the androgen receptors, which is usually occupied by testosterone. To really see them in perspective, let us do a hands-on demonstration. One might think that the effect seen here is only of seconds. Why worry so much? Well, in sports like athletics, the cost of a few seconds could be a medal. If steroids are so beneficial, why don't athletes use them all the time? Well, because like everything, they too come with a catch. The effects can vary from increased probability of heart attacks, liver and prostate cancer, not to mention the ethical concerns of outright cheating.
So the next time you see someone set a new world record in any sport, pause and think about the cost they might be paying.
Our country's performance in Tokyo Olympic this year was commendable, isn't it? The Olympic Games are known as the world's foremost athletic competition where thousands of athletes participate from all over the world. Chemistry plays a big part in our everyday lives, and one can easily observe the role of this branch of science in this event. Today we'll be discussing about one of the widely used fibers in Olympic, rayon, and its production in a chemistry lab. For its preparation, take ammonia and copper sulfate in 2 beakers. Mix them together slowly and make sure that the mixture contains 40% of ammonia solution. Tetraamine copper 2 sulfate solution is formed, which is dark blue in color. The resulting solution is complex. Now start adding cotton to the solution until it's saturated. Now take the resulting mixture in a syringe and inject the syringe in the beaker containing sulfuric acid. Complex reactions will take place and the cellulose in the tetraamine solution will start to precipitate. The sulfuric acid reacts with complex compound and copper gets dissolved in it. Soon we will see that the light blue fibers turn colorless as copper salts get washed away. Rayon is a very versatile fiber and so its use in Olympic is variegated. Due to its silky appearance, it is used to make ribbons for medals. Also, it is used to make flags for ceremonies. As rayon is generally used in textiles, we can also see its use in the dresses worn by the participants in the opening ceremony. It is generally used to make bandages and surgical dressings for medical aid.
An amazing performance by all the contenders.
Now, I invite Mrs. Bhavna Seth to express her gratitude on behalf of the entire team and declare the Olympics meet closed.
A warm and graceful morning to one and all. It's my proud privilege to propose the vote of thanks on this special event of hands-on science on behalf of Science Department. My first and foremost thanks goes to the Almighty God, the Creator of all, for making today's event a resounding success with His blessings and grace. I would extend my warm and sincere thanks to the management and the heads of institution for giving their constant support and guidance. A heartfelt thank you to all the participants for showcasing their talent and the parents for their immense cooperation. My sincere thanks to all the teachers and the technical staff for their support and consistent efforts. Thank you one and all for being part of today's program.
Thank you, ma'am. The Science Olympics not only witnessed the power of excellence in science, but also the power of togetherness. With this, we declare the Science Olympics 2021 closed. It's time to move on, and we all shall knock on the door of success by exploring the key.